Okay guys, in this video, again, I'm going to try to go as at a good pacing, all right? But basically, this video is going to go over negative exponents. Now remember, I have posted the worksheets. If you've either misplaced it or whatnot, you can look in Schoology, and I've posted the packet for all of the worksheets for you guys. Those of you that have been absent or sick at home and been doing remote learning, please make sure you stop by and see me on your own time and get the packet. All right, so let's jump into negative exponents. So notice that it says negative exponents can be rewritten using positive exponents, okay, using this rule, okay? So what you have to keep in mind for this one is it's 1 over x to the a. 1 over x to the a. So because that exponent has a negative sign on it, I have to do 1 over. Remember in class, I basically said to you guys about the happy place, right? If the particular variable, okay, or base has a negative power, he's not happy where he is. So in this case, we would move him to the denominator. All right, so let's look at 1 through 3 very quickly. The answer to this one is just like what the rule says. So this one is 1 over x to the positive 5. Again, the way I think about this is I'm putting this over 1, and then I'm telling myself, hey, you're not happy where you are, so I'm bringing him down to the denominator. And once he makes that transfer to go across the division bar, basically that negative sign becomes like the division line, okay? And so now that negativity is gone, and then down here is the positive exponent. Okay, this one, notice there is no negative on the 3. It's just on the m. So let's leave the 3 in the numerator, and on the bottom is m squared. Okay, again, he's the one that was not happy, so he has to go down. Okay, now on this one, watch carefully. Now, I said again, on this one, there was no negative on the 3, but when I say negative on the number or coefficient, I mean that there's no negative power. So it is okay that for number 3, you have a negative 7. That does not mean put this negative 7 or this 7 in the denominator. Leave that like it is, okay? Focus on the two bases. So here I have a to the negative 4. He's going to go to the denominator. And b to the third, he's happy where he is. So the answer becomes negative 7 b to the third, and it was the a that needed to go to the bottom. All right, so again, replay that if you need to, and let's get into some trickier ones, all right? Now, for this one, number 4, you notice that you have basically w to the 7th times w to the negative 9. So if I go to my cheat sheet for a second, I'm getting my cheat sheet, and I say, oh, look, these guys both have the same base. They have different exponents or powers, so therefore, the law says that if I have the same base and different powers, I should do addition. You guys see that? So then on this one, because they're w's, I'm going to put w 7 plus negative 9. When I add that together, I'm actually doing subtraction. So I get w to the negative 2. And he's not happy where he is, so this becomes 1 over w squared. So that's the answer for number 4. All right, I'm going to jump around. Let's go to, I still will go ahead and go in order, but I'll start jumping around in a second. Let's go to number 5. Let me zoom in so you guys can really see it. All right, so for number 5, again, I can't stress enough that when you simplify these expressions, just group everything that's like together. So in my mind, I'm multiplying all these things here. They're all sitting next to each other. They're all kind of married, but I still have to simplify the whole thing. So 4 times 5 is 20. So I'm telling myself 4 times 5 is 20. Okay, that's going to be my number part. But then when I group my c's together, so I'm timesing c8 times c to the negative 5. All right, and again, that still comes from the product rule that if I have the same bases, different powers, do addition. So what's going to happen for this one is I'm going to have c, again, I'm just going to subtract c to the third. And then when I group my d's together, I had d to the negative 3 times d to the negative 1. So now watch carefully on this one. This becomes d to the negative 4 because, again, I'm just doing negative 3 plus negative 1. So d to the negative 4, I had to do addition because they had the same sign. However, when I put my final answer, remember that the D is the guy who's not happy. Again, Again, this is a 20. So the final answer to this is 20, c to the third, the d to the fourth is on the bottom. All right, let's keep going. I'm trying to see which ones are hard. I feel like this is okay. This is negative 18, and this is a x to the negative 8. So let me just group it, and then I'll just let you get the answer. So negative 18 came from 6 times negative 3. But for the x to the negative 8, guys, times x to the negative 3, the product rule says to add those together, you get x to the negative 11. Watch your rule of integers. But the final answer is negative 18 over x to the 11. Okay, all right. Skipping number 7. Okay, let's look what happens. Remember how I talked about if there were numbers and also variables inside here? So I want to show you that on number 8, you have to, again, do everyone raised to this number out here, this exponent. So this is the law. I'm going to put it over here. It's not on my cheat sheet, but I told y'all to write it down. If I have AB raised to the m, remember that every single base that's inside of the parentheses gets raised to the m power. So this is A to the m, B to the m. So if I look here, this could be like my A, this is my m, okay? So I'm going to do 8 to the negative 2. Sorry, positive 8 to the negative 2. And then what I notice here is this is the power rule. Remember the power rule says, and I'm going to get my cheat sheet, that if I have a base raised to a power raised to another power, multiply. A times B. So in this case, I have p to the 5 raised to the second. I'm going to multiply that for 10. So this becomes 8 to the negative 2, and this is p to the 10th. But again, that 8 with that negative 2 is not happy, so that means he's going to go down to the denominator. So to clean this up, we're actually going to get p to the 10th in the numerator and then 8 squared on the bottom. So the answer to this is basically 1 over 64, okay? But we have that p to the 10th. So the final answer is p to the 10th over 64. And I'm going to transition to a sheet of paper. Everybody good on that one? All right, so now let's look at number 9. All right, for number 9, we had 5y squared raised to the negative 3, or negative third. So again, this is like the A, raise it to this, and then again here I end up raising this to this, so I'm multiplying. So I have 5 raised to the negative 3, which becomes, right, 1 over 5 cubed. Okay, and then when I expand this out, that's 1 over 5 times 5 times 5. We should get 1 over 125. All right, so that takes care of my number part. 1 over 125. But now I'm still ready to go do my multiplication with the 2 times 3. So my y is to the negative 6, 1 over 125, and then I had y to the negative 6 because I multiplied 2 times negative 3. However, the y is not happy where he is, so move him down to the denominator. So the final answer to this is 1 over 125, y to the 6th. That's number 9 in the practice. Okay, let's keep jumping around. Now let me go to number 13. For number 13, right here, I have c to the negative 2, d to the negative 1, c to the 7, and c to the negative 2. Now, I said this in class that, again, whoever's not happy where they are, move them. So in my mind, this guy is going to go down. This guy is going to come up. And I like to just, use arrows. So he's going to come up. And then d to the negative 1, this guy here, he's going to go down. I'm going to put a down arrow here. So now when I sit back and I simplify this, I'm saying this is the only guy who is happy where he is. So when I look at this, I go, okay, you are going to go, according to this, up. So that's c to the 2nd over. This c to the 2nd, or negative 2, is going to come down. But there was already a c to the 7 down there. And the d to the negative 1 came down as d to the 1. So now everyone's happy. And then from this step, everybody, we're going to use what is the quotient rule, which I'll put in the other video, the difference one, the quotient. And this one says, hey, if you have the same base and different powers, do subtraction, A minus B. Y'all see that? Okay? So now when I look at my C's, I'm thinking, oh, I should subtract those. And you could do that. You could do C to the 0, okay, which is 1. Or you could do this, one more step. You could rewrite the C squared, but on the bottom, I go back to the product rule, right? If I have base, power, power, just like this, base with one number, base raised to a different number, do addition. So I'm going to make that bottom one C to the 9, D to the 1. And now, guys, you see that? They're the same bases, different powers. Now I'm ready to apply the quotient rule, all right, where I do subtraction. So the final answer to this is I know that 2 minus 9 would be negative 7. So just to be clear, we did C to the 2 minus 9. And then that D to the 1 is the only one of his type, so let's leave him alone. And now I have C to the negative 7 because I subtracted over D. But again, he's going to come down because he's not happy. That's 1 over C to the 7, D. Again, replay it if you need to replay it. Take your time. All right, last one I'm going to do on this page is number 15, and then I'm going to move to some harder ones. All right, here we go. For number 15, again, this is the practice. Negative 10 m squared n is in the numerator. And then I had 2m to the third n to the negative 5. Now keep in mind, there is no, on this negative 10, that's just a number. There's not like we see, guys, a 10 raised to the negative 4 or negative 2. So this is fine. So I'm just going to do negative 10 divided by 2, which is negative 5. Okay? And then the person who's not happy where he is basically that n to the negative 5. So he's the one that I'm going to move up. And I'm going to rewrite everybody else the same. So the m squared is there, an n is there, but I'm putting n to the 5th at the top, division bar. And then, again, that 2 is gone, so I got m to the 3rd. I took care of my division. Okay, everybody look at that. So now I have negative 5, and then what does this say? I'm not ready right now to do my subtraction. My eyes go to this one, which is the product rule. So I'm going to write this as m squared n to the 6th, and on the bottom I have m to the 3rd. And now I'm going to come back and do my subtraction with the quotient rule. Okay? All right, so let me move here. So now I also showed you guys how to understand this. If you don't understand how to apply the rules, you can always expand stuff out. Okay, so I hope this is not confusing. But remember, you're going to do 2 minus 3, which is negative 1. But what I want to show y'all is this. Negative 5, m, right? The n to the 6 is the only term that looks like himself, so just write him again. But on the bottom, I'm expanding out that this is m times m times m. Y'all see that? And then remember I told you you can cancel out pairs. So if I cancel out those two pairs of m's, I notice that there's just a 1m on the bottom. So the final solution to this is there's 1m left on the bottom. I hope that makes sense to you. Again, if you wanted to do just straight out subtraction, then here's the alternative. Basically you had, I'll go here, negative 5, right? You had m2 minus 3 and then times n to the 6th. And this became negative 5 m to the negative 1 n to the 6th. And again, this is the guy who needs to go down because he's unhappy. So you just bring him down. And then again, that's where you get that solo m by itself. So whichever one makes sense to you. Okay, I'm done with that one. All right, so now let's move on to the trickier page. And so that's this one here. The ones that have numbers, again, 16 through 25. And then there's this real crazy challenge question. I am going to do that one. A lot of fun. I think they're fun. Okay, remember this is about negative exponents. So now let's get to, I'm going to do number 18. Okay, so for this one it was negative 4 p q to the 5th r to the 3rd divided by 8 p squared q squared. Okay. All right. So remember, it's important to group them. Okay. So in my mind, I mean, just got some highlighters here. So I'm going to say, oh, my p's are going to go together. My q's need to go together. And I'm noticing that they're, one's in the numerator, one's in the denominator. So I got to do quotient rule and do subtraction. And then here are the r's. Okay. All right. Everybody good? So this is -4/8, which becomes -1/2. I just reduced and divided them both by 4. And then again, this is a p to the 1. And again, you can tell yourself, hey, I'm subtracting, and this is p to the 1 minus 2, because again, I'm using the quotient rule. And then I have q to the 5 minus 2, which would be a +3. I'm just showing how the quotient rule. And then the r is 3 minus 10. So when I clean this up, I still get that -1/2. And I know this right here is -1, right? So if this is p to the -1, he's unhappy up here in the numerator. He needs to go down. So that's just a p there. This is 5 minus 2, which is q to the 3rd. Has a positive exponent, so he's going to stay in the numerator. And then 3 minus 10 is r to the -7. He's not happy up there, so he needs to go to the bottom. Okay, pretty easy. Okay, take your time. All right, so now, again, that means I'm leaving you to do 16, 17, 19. And I want to go to the mixed practice. So this is the one when it says mixed practice on the worksheet, guys, and I'll just show it to you. This is the one that has like everything. So it's going to have like the addition one, adding and subtracting monomials. It's going to have the product rule, the quotient rule, the negative power, all the rules. It's fair game. All right, so let's get to number, I'm going to number 20. I'm going to do maybe like 3 of these really fast. So I have 4x cubed y to the 6 raised to the -2 plus, so I know I'm going to be doing something with combined like terms. Right, now as you're writing this down, please listen to the sound of my voice. I always say that. I can't stress to you enough, it's the same habits that I incorporate in class or these videos. You notice I take my time. You notice I write every single step. And guess what? I can do it mental. I can do it faster than this. But I can't stress that if you break down every little thing, you can see how to simplify your answer. Be careful. Don't go fast. Don't just look at it. Oh yeah, this is y to the -12, and then you quickly just write down a +12 and you mess up. Okay, here we go. So 4 raised to the -2. I'm putting that in parentheses. So I'm thinking about the negative exponent rule. I know that this is a power rule. So again, if you need to see the cheat sheet, is I see a base raised to a power, and then out here is another power, so I'm going to multiply. Again, that's that one right there. Raised to a power, so I'm going to multiply. So this becomes x to the -6. You could have did 3 times -2. Y to the -12, I put a plus. Now I'm going to come back before I go here, and let's clean this up. Remember, this is 4 to the -2, so that is 1/4 squared. There's a 16 at the bottom. And these two guys are not happy, so guess what? They're down there with the 16. So that's the first term. Okay. Now I'm going to go and look at this one here. And I had 2 to the -3 multiplying for x to the -6 and y to the -12. So back here, I'm doing 2 to the -3. That's 1/8. Right? Am I right? Yeah, 2 to the 3rd is at the bottom. So that's why I'm going to change that to an 8. Do y'all see that? 2 to the -3. And I don't know if I've ever expanded it out for you, but let's just be clear, and I'm just going to come here real quick. This is like saying, hey, I had 2 to the -3. So I know it's going to look really weird, but this is like I said, it's 1/2 times 1/2 times 1/2. Because you just leave the base as a 2, and then this would change to a +3, but again, the 2's are at the bottom, so that's where 1/8 comes from. All right, so now again, down here, x to the 6th, y to the 12th. And you're looking at this like, oh, Miss Mosley, what do I do with that? What do I do? They're just fractions. If these two, and that's the part I was talking about, very, very important, that when you look at adding and subtracting monomials, it says, hey, combine like terms, but do not change the common variables and exponents. So don't mess with the x to the 6 and the y to the 12. Just focus on the coefficients and combine like terms. So if I was adding these fractions, I need to get a 16 at the bottom of the second fraction. So this becomes, again, 1 over 16 x to the 6, y to the 12. And this is also 1 over 16 x to the 6, y to the 12. So now I can add this. Y'all see that? But again, leave the denominator alone. So this is 2 over 16, which becomes 1/8. Yes. But leave the x to the 6, y to the 12. So this was pretty tricky just because I had a fraction. All right, let's keep going. Now I'm going to do number 23. So for this one, it's 3xy squared, 2x to the 4th, y to the 3rd, all divided by, all right, here we go. So again, keeping it simple, remember that this is the same as having two of these being multiplied out. This could be one big base. So this becomes 9. And then this is x to the 1 times x to the 1. So 1 plus 1 is x squared, and then y squared. That takes care of the front parentheses. Back here, there's nothing to do here. So I'm just going to transfer this down just like it is. And then I'm also going to rewrite my bottom with nothing to do there. All right, so now I'm going to focus on the number parts. Excuse me. 9 times 2 is 18. 18 divided by 6 is 3. All right? And then very carefully, I'm grouping together, excuse my voice, I'm grouping together the x's. See that? And then there's this x to the 8th. For my y's, y squared, y to the 3rd. On the bottom, there's just a y. Okay? So again, I got something, there's no division there, I'm just separating. So I gotta combine all this stuff with my x's, combine all my stuff with the y's. Okay, and let's see what we got now. So remember, again, I got 9 times 2, which was 18. 18 divided by 6 is 3. All right, so now I have 3. And again, I'm going to add those, which is 6. But I still have that x to the 8. I'm not ready to do my subtraction or quotient rule just yet. I'm adding these two. 2 plus 3 is 5. And down here I have y to the 1. So here's the final answer. Now I'm ready to group these together and do the quotient, which means I have to do subtraction. So I get 3x to the 6 minus 8, y to the 5 minus 1, which becomes 3x to the negative 2, y to the 4th. The final answer is 3y to the 4th, and then the unhappy person goes down to the denominator. All right, hopefully that helps you. And the last one I'm going to do for the mixed practices, let's do 25, and then I'll do the challenge questions, and that is all she wrote for negative exponents. Again, take your time. All right, here's this last one, number 25. 6. I wrote it wrong. This is a 3. So I know that 6 times 3 is 18. All right, here we go. All right, so for this one, again, like I said on the top, I got 18. And the cool thing about just going across with the numerator is I'm telling myself, hey, this is b to the 1. This is b to the 5th. So 1 plus 5 is b to the 6th. Now I'm going to do my c's. So So I got c to the third and c squared. I got to add those for c to the fifth. And now I'm going to go down to the denominator and multiply 5 times 2. Down here I have a 10. And again, I'm going to stay true to the colors. So in orange, let's put b to the 5. It's going to multiply with b to the third. Then we do addition. 5 plus 3 is b to the 8th at the bottom. And then for the c's, I'm going to add those together for c to the 8th. Everybody see where I got that from? And now I'm just ready to reduce this fraction. And I believe the greatest number that can go into both of those would be just 2. I'm trying to think. Yeah, 2. So I'm going to make this a 9 and this a 5. Divide by 2 to both of those. And then again, I'm doing quotient rule for subtraction. 6 minus 8 is b to the negative 2. And then right here, 5 minus 8 is going to give me c to the negative 3. So the final answer to this is actually 9 is in the numerator, 5b squared c to the third. Okay, alternatively, if you want to see this, you could try the expanding method, which again, it's 9 over 5. I just want to show you what it looks like if you just break these down. So if I do 6 b's up here, and I do 8 at the bottom, I know you don't have time to do that, but I'm just showing this. It's a b. Okay, and I start canceling out pairs carefully till they're all gone. Now what do you notice? You see there's 2 b's on the bottom, and then there would be 2 b's in that location. Same things with the c's. If I do 5 c's and then 8 c's down there, I think that's 8, and I carefully start crossing them out. Gotta pay close attention. You notice that again, 3 c's are left at the bottom. All right, so that takes care of that. And I don't know where my timestamp is right now, but I'm not going to do the challenge problem. I'll just show it to you one day in class or let you guys do it, or maybe it's a bonus question. All right, so that concludes this video. Again, on what we went over was negative exponents, but again, you did get to see for negative exponents, you still got to see the product rule, you got to see the power rule, combining like terms with adding and subtracting monomials, and the quotient rule. And you now know how to do the negative exponents, which is 1 over, and they're not happy, move into a happy place. Everybody good on that? All right, I'm going to stop the video here and do the 0 exponent rule in the next video, and then also show division, which has to do with the quotient rule. Thanks, guys.